So now let's look at the solution for our problem concerning waning immunity. First things first, the constant waning time should be defined as 2 times the infectious time. We can show this mathematically using the equations we have for the derivatives of S, I, and R with respect to time. We know that after a long period of time, we want to attain a steady state situation in which the number of people in each portion of the population, susceptible, infected, and recover, stays constant. Since we want to find out how long people should spend in the recovered stage, we start with the time derivative of R and set that equal to 0. Since we know that R dot now has an extra term added to it, or actually subtracted from it, showing the number of people that are leaving the recovered population and going back to the infected population, we can set these 2 terms right here equal to 0 as well. Just a note, I've used CINF to stand for the infectious time and CWAN to stand for the waning time. Now if we just do a bit of algebra, we come out with the answer that R equals 2I. Since we know that we want the number of recovered people to be twice the number of infected people, we can plug in this extra information to the equation above and end up with the answer that the waning time is equal to twice the infectious time. This leads us directly into the next part of the problem. We define R2S in the same way that I2R is defined, except that we replace infectious time with waning time and I step with R step, as you can see right here. Now moving on to our recursive relations, for each element in the step plus 1 position, we need to take into account the value of the previous element and the number of people added and subtracted from the population during each time step. We know that the one thing that has changed in this model from the standard SIR model is that people are now moving from the recovered population back to the susceptible population. This is why we've needed to add in this extra term R2S, which we subtract from R and add to S. Now let's run the program and see what we get. Now here we see we end up with this fancy graph, which has 3 different series for the 3 different parts of the population we're looking at. Remembering how we set the initial values for S, I, and R, we know that the blue line here stands for the susceptible population, the green line stands for the infected population, and the red line stands for the recovered population. At the maximum time that we're looking at, 60 days, we can see that the red line is graphing twice as many people over here as the green line is marking, which is exactly the answer that we wanted to end up with. Congratulations on successfully completing the first problem of Unit 3.